Welcome to Chapter 0. We call it Chapter 0 because this chapter is actually not in the textbook. This is on measurement. And what we're going to do is go through the means at which we record our measurements and how you can share it. And we're going to keep an emphasis on being consistent so that we can share this information with people all around the world. So obviously early measurements had problems with being inconsistent. There were essentially right there I got 3 different units to measure length. Who knows what a cubit is? Fathom, I think, depth of water. We all heard of feet. And so what scientists had to do was figure out that they needed a single set of units, so they all would use the same one. And the set that they used was what's called the System International, and it's based on the metric system. System International is based on the French words. So let's look at the fundamental units of the SI system. Length, and you've probably all heard of a meter. Mass is a kilogram, and we'll talk more about what mass is. And the fundamental unit of time is a second. Now these are the 3 most important ones for us. These are the ones we're going to use over and over and over. Other ones you may hear are degree Celsius or Kelvin. The amount of a substance is called a mole. You probably use that in chemistry. And luminous intensity, how bright light is, that's a candela. And that one we might use a little bit here. Now, a derived unit is a unit that is found by taking 2 fundamental units and putting them together to make a derived unit. For instance, speed is distance divided by time. So its units will be meters per second. You've probably heard of miles per hour. That's a unit of length, mile, divided by a unit of time, hour. Here is meters per second, a unit of length, meters, divided by a unit of time, second. Now, we need to use units. If you don't have units, you could just say to somebody, I'm 68. 68 what? Well, I'm 68 inches tall, which is about, 1.4 meters. But I could say I'm 1.4, and people will be like, well, what is 1.4? 1.4 meters. Sometimes people ask, what do you weigh? And you say 150, and they kind of know that you mean pounds. But for the most part, we need to use units. And the units we're going to use, like I said before, are the meter, the kilogram, and the seconds. Do not use centimeters, grams, and seconds. When we go to do the math and go to make other derived units, if you use the centimeter and the gram, we're going to have to do all kinds of little conversions to make it work, and we don't want to do that. Here are some prefixes. Now what a prefix does is allows you to take a large amount of a unit and express it in a smaller, in using a smaller number. For instance, we could say that that I live 5,000 meters from the school, but rather than say 5,000 meters, we would say 5 kilometers from the school, and a kilometer is equal to 1,000 meters. The 3 that we'll be using over and over again is the kilo, the centi, and the milli prefixes, and you've probably heard of all those before. Especially heard of all of them when you talk in terms of distance. Now let's talk about mass. Mass is the measure of how much material an object it has, how much stuff is in it. You're all made of stuff, but you never really describe yourself in terms of mass. You always describe yourself in terms of pound. But we're going to use the kilograms in this class to talk about how much stuff is in you. And we'll talk about what inertia is also, which is how hard it is to move something. You don't want to confuse mass with weight, because the weight is how much attraction you have to a another object, namely in our case the Earth. That's how much weight we have. But if you go to the moon, you're attracted with less force, so therefore your weight is different on the moon. However, you're always going to have the same mass on the moon. So that's why we'd use mass to describe who you are, as opposed to using weight. It's more accurate. Volume is the amount of space that something occupies. Units are the liter. You can see right there I have 1,000 milliliters would equal 1 liter. There's that milli prefix. Milli means 1,000. 1,000th of something. And you've probably used a graduated cylinder. That's what the picture of the person looking at the graduated cylinder is for. And we also show that volume is also three-dimensional, as opposed to distance, which is just really two-dimensional. Now, some common English to metric conversion, though I don't use these very often. A centimeter is equal to 0.394 inches, but the one I always remember is 1 inch is equal to 2.54 centimeters. I use that one a lot. The pound is equal to 0.45 of a kilogram, but the one I always use is 1 kilogram equals 2.2 pounds. That one you should be able to use, and I'll teach you a little trick about dividing by half and taking off 10%. Quart is equal to almost to a full liter, and 1 liter, therefore 1 liter is equal to 1.06 quarts. When we buy soda in a 2-liter bottle, we're basically getting a little bit more than 2 quarts of soda. But you probably go to the store and buy milk in a quart. So, now, one other thing we talk about is the accuracy of your experiment, or your measurement, excuse me, and that's percent of error. And the percent of error is often taken by taking the accepted value and subtracting your experimental value, that's what you measure, and then dividing by the accepted value, and then taking a percentage. And that will tell you how far off something is. For instance, if you measure let's think of a good example. If you measure the mass of a 10-pound bowling ball and you get 9.9 pounds, you've made an error because it's probably exactly 10 pounds. So that percent of error, which I think is roughly 1%, you would find that percent of error using this formula. So in summary, these are the main points. The base units are the meter, the second, the kilograms of the SI system. We can find fundamental units mathematically to form derived units, such as the unit for speed, meter per second. We use prefixes that change the SI units by powers of 10, milli, centi, kilo. The International System of Units allows scientists and engineers to exchange data because it's consistent. Everybody in the world has agreed to use it. And we're going to use MKS units, kilograms instead of grams, meters instead of centimeters. We're going to use seconds for time units. And once again, how to find a percent area is by taking the accepted value, subtracting the experimental value, and divided it by the accepted value, and then multiplying that times a percentage.